Hey, what's up, Easy here. This is a little story I wanted to tell for quite a while, and I just never really got around to it, so this is kind of like a vloggy video, some stuff that I did, some upgrades that I did to my computer about a year ago. And what you see here is some new radiator fans, two 50mm MOSFET heatsink fans, a 5-channel fan controller, and an assortment of two-way fan splitters and extensions for the fans as well. So, you can see here that I posted this on Twitter in April of last year, and today is February 10th, 2016. So I'm literally wrapping around a year, and I didn't post that until I'd already been done with this project. So the purpose of this originally, the original intent was um, this little clip of footage here. I show how my power supply shorted out, and the cause of it was this 8-pin power connector melting 3 of the power pins. The 4 on the inside are power, the 4 on the outside are ground. And originally I thought that it was because the radiator was like pinning up against the wires and like the heat from the radiator caused it. Well, that was a misdiagnosis. The actual cause was a combination of the MOSFET heatsink, lack of airflow, and power draw from the CPU because it was extremely overclocked at the time. So the way I'm addressing this is I have some of this heat resistant mat, and it's also semi like fire resistant as well. It takes a long time to melt and deform and catch on fire, and it dissipates heat extremely fast as well. You can literally like get it melting and then let it cool down for 2 seconds and touch it, and it's just barely warm. So I have insulated this connector with some of that mat and wrapped it very loosely with some heat-resistant duct tape as well. So that will attempt to shield out some of that extreme heat from those MOSFETs, because those MOSFETs are what makes all that heat. And you can kind of see here, you got to remember too, there's no fans on this radiator. You can just see how much room there is to work with. Like that connector is in a bad spot for a liquid cooling setup, and this is a Corsair case and a Corsair cooler, so those two were meant to go together. It's just a poor design by Corsair. Now what I'm doing here is I have clipped, I don't know if that's electrical tape or some of that heat resistant tape, but I have some stripped out screws on this radiator, and to fix those, what you can do is just take and cut a little corner of some tape off and lay it over the radiator hole, and then press it in with the screw. Don't screw it in, because it's only good for one use when you screw it in, because it'll, smash the tape and mess it up. But just press it in to make like a dimple, that way it doesn't fall out. And you won't have to worry about those screws just, not doing anything anymore. As long as you haven't, totally dick the hole, it will grab onto that tape and thread in. So this is what the radiator looks like with the new fans on there. As you can see, they look great, and those were the old fans, the Cooler Masters. There wasn't anything wrong with those. They were just some sleeve bearing fans that you don't want to use sleeve bearing fans mounted horizontally. So now you can see just how little room there is. You can't even see that plug anymore if you're looking for it. So you can see just how tight it's tucked back in there, and there's like, virtually no airflow as well. So that was the cause of that getting so hot that it actually melted that plastic. I'm sure that that was probably, 130 Celsius easily. So now what you see is just, this is like my drive cluster orientation. I have one SSD and 4 mechanical hard drives, and these wires here are the wires for the fan controller. This is just to kind of show how long they are if somebody was wanting to know, how long the wires were when the fan controller was mounted in a bay. And they're long enough to stretch to any corner, so that's not really an issue. Especially when you factor in that when you hook it to a fan, the fan's got its own wire as well, so more than enough wire. Now what happened in the process of me like doing a little bit of like cable management, this SATA connector here is for my water pump on my cooler. So, and it's non-modular, so it's literally the wires go inside of the cooler to the pump and are like soldered on a PCB in there. You cannot remove it. So it just snapped off the back plate of this cooler, and it wasn't like me tripping on it or doing it wrong or anything. It was damaged somehow from before, which I don't know how, because I literally like hooked it up and then never touched it again. Regardless of how it happened, and the way that I chose to address it was I used a Molex to 2-pin fan header connector. It was basically like the same gauge wire as the SATA power, because on the SATA power it was just 2 wires as well. And what I did was I bent all of these pins at an angle to where when I plugged it in and it didn't have any of that like plastic on the back to help support it to make connection, that it would still make connection, because I needed to check the wires for voltage. So what I did was I went ahead and got out a new SATA power and a new an extra Molex plug, because I was already using one that had one for the fans on the H100i and then one for the fan controller. So what I did was I just wrapped a zip tie around it to hold it in place. I bent the pins down, connected it, that way they would make contact, wrapped a zip tie around it to where it'd stay, and then I shaved off one of the wires. That way I could probe it with a multimeter to check it for voltage, to make sure that it was 12 volts or if it was 5 volts or whatever. And I confirmed it was 12 volts, which was, that's good. So this little clip, this is the Molex to fan connector here, and what I did there as well is I checked the voltage and the resistance on those pins to see how it was wired, because you can wire a Molex to 12 volts, 5 volts, and if you wire 12 and 5 together, it makes like 7 or 9 or something like that. So I wrapped that wire up and then scraped the other to make sure that was a ground and it wasn't like two hot wires. Confirmed it was a ground, so then that made everything pretty simple. I took and prepped my system for a solder job, and basically just used a giant sheet of that mat, cut a slit in it, that way I didn't have to take my water pump off the CPU and have to reseat it and put new thermal paste on and all that crap, which is actually a bigger headache than it sounds. So just got the wires marked and already had them like twisted together, and just threw some quick solder on it to fix it up. This is what it looked like after I finished. It looks, other than the tape wrapped around it, it looks like it belongs there. In all honesty, I think that I don't understand why they use SATA. I mean, I know like power supplies and the stuff that we're using these days, it's more common to have SATA than Molex, but there's nothing wrong with Molex, and the Molex connector is way more durable than a SATA connector. So what I'm doing here is just powering on the system and then checking to see if the wire is smoking or hot, and checking to see if I can feel vibration on the pump to verify that the pump is actually working, because if that if that solder was bad or those wires were backwards or something, that pump would not work. So then I am loading up Corsair Link. I was using Corsair Link at the time, and it's kind of useful, I guess, for this specific situation. I could have checked this in BIOS, I guess, too, since the pump the pump has like a fan header with one wire on it, I think, and you plug it into the CPU header of the motherboard, and that will tell you your pump RPM. So that is just to verify that the pump is actually spinning, even though I already verified it that that it had vibration. So now I move on to checking these 50mm fans, because remember this was what the whole project was supposed to revolve around, and already it was a nightmare breaking that SATA connector and having to uh, find a Molex connector to solder it to it and fix it. So this is just a little test of the fan controller and the fan, so you can see that they definitely push some air and that the fan controller does work. And this is what if I mentioned it earlier, if I forget already, it's inside of this fan controller. Um, it's just like an empty tray. It's just a big hollow area. And what I decided to do to make a little bit of room where my hard drives were, I could mount the SSD up here inside of this tray, and then I could like orientate my hard drives differently so they would allow a little bit more airflow through the front of the case. So what I'm using to do this is just some Velcro with some sticky on the back side of it. And what I've done is I've just put it in like 2 spots. Now, if you do this as like a word of warning, don't put the double-sided tape or Velcro or anything over the serial number, and probably not over the stickers, because the warranty on SSDs, it says like specifically that they have to be mounted properly in a drive bay, even though that is totally ridiculous, because SSDs can actually like withstand an impact of like hundreds of G-force. Like you can like drop them off a building and they're fine. So, but they might void your warranty if you know, mounted it with tape. So here I have the fan controller mounted, and I originally had 3 fans in the front, but now I ran into the problem that with the new fan controller in there, the way I had them mounted, there weren't actually mounting holes for 3, there was mounting holes for 2, and I stuffed an extra one in there. I had to overlap the middle fan on top of the top and the bottom fan because there just was not enough room. So that's what you're seeing here, and this is just kind of like a test fit to see if the front cover will actually snap on and it's not bowed out or anything. And there's literally probably like millimeters behind there as far as clearance. But it did work, all was good. And the way I mounted those fans is, I think I got screws in a couple of them, but then I, basically just zip tied one fan to the other. And then here you can see that I was able to change the orientation of these drives to where it's 1 drive at the bottom, empty spot, 2 drives in the middle, empty spot, 1 drive at the top. That way the air has more areas to pass through. Now on to the fun part. So this is like the mess of paper that I created. I was making like paper mock-ups to figure out how I was going to fabricate a bracket to mount those MOSFET fans, because there's just nothing to mount to right there. Everything is, delicate that you don't want to be drilling into, and there's just, not a lot of stuff. So this was the first failure right here. Just a weird bracket coming from the left side to the middle, and the reason why this wouldn't work is because I couldn't get the proper angle on it, and the bracket was in the direction of the air, where I wanted to push the airflow. So then this is like version 2.0, and this is, basically what I went with here. And it's just literally mounts to the bottom radiator fan, and then comes up and then mounts to the MOSFET fans. And I'm using just a big sheet of aluminum. I'm not sure exactly what kind it is. It's just doesn't bend that easy, and can bend back and forth quite a few times before it breaks. So it's perfect for holding these fans. So what I did is I marked the corners there to where the fans wouldn't be obstructed at all. But then that one was a failed attempt too. This is like version 3 here, and this version was like much higher, and like the offset was different. That way I could put these like kind of like weird bins on it. And the reason why like I needed the weird bins is because like the MOSFET heat, you don't want the fans directly on the MOSFET heatsink, so the fans needed to be propped up. The top of the fans needed to be propped up a little bit, and literally the bottom of the fans are like butted up against the water block on the CPU, so there's no like, movement, front to back movement at all. They're like perfect fit in there. All they can do is tilt one way or the other. So they needed to be tilted upward, but they also needed to be tilted at like the right side down and the left side up, because I wanted the heat to be pushed towards the back of the case, because the back of the case there's an exhaust fan. Now I could push it towards the front of the case, but then pushing it towards the front of the case, it's just gonna loop back around and go right across the CPU and the water block and go out the back of the case. So straight out the back of the case is where I wanted it. So I had to put it at like, a tilt up and a tilt to the right, which is what this funky looking bracket allowed me to do. And it's basically got two different bends in it. One's like a 90-degree bend, and one's probably like a 30-degree bend. And then the 30-degree bend is actually a little bit, they're not symmetrical. One of them's a little bit different angle, and that allows the tilt, the sideways tilt. So that's what it looks like after I trimmed it up with some tin snips, I think is what I used. Surprisingly, it came out pretty good, even though those tin snips were, some savagery. But this is like a mock-up of what it's going to look like when it's mounted. And another problem with all of that was that the MOSFET heatsink is not centered to the center of the radiator on the fan, so it's like offset. So what I'm doing here, this is the process of how I scored the piece of aluminum to actually drill these holes. And it was literally like I sharpened a nail or something and scratched it through the bottom side of the fan hole. So there's the holes. They weren't totally perfect. They're actually just a little bit crooked, I think. And I wallered them out a little bit as well. But the holes for those screws were huge. They're like the giant fan screws. So that's what it looked like finished. Perfectly centered over the MOSFET heatsink, angled at perfection. They are angled down on the bottom and then to the right. And this is buttoning her up. Totally done. This was an all-night project. It was probably like 6 full hours to do all that. So after I get everything back together, I noticed that this fan controller's got this like super bright glaring light, and the light actually is not isolated from that first slider. So there's like a gap in the like square area where the light is, and there's just a huge like hole to the first slider for the fan controller. So then it reflects over into the first slider, and it like illuminates the slider partially. So I got some of this mat out and then just cut a little section of it, stuffed it in there. Which, I mean, this is how it should come from the factory. It's kind of shitty on their part, but tucked it in there, no problem. So now no more glare off to the side. And then shoved it back in. Was almost satisfied, but I hate lights. Totally hate lights. My system's totally blacked out. So what I did is I took a piece of that heat-proof duct tape and just put it right over that light, and that was the finishing touch right there. So this is what she looks like a year later. I took this footage literally as I was making this video, so this is literally what it looks like now. And as you can see, there's not really much changed. The GPU is in a different PCI slot, which doesn't matter on that board because it's got 2 X16 slots, and then the side cover fans are now exhaust instead of intake, and the bracket for the MOSFET fans is painted. I didn't take it out to paint it. I literally just taped some newspaper to everything and painted it inside. But everything is still working well. Really pleased with how everything turned out. And as I mentioned before, I hate lights. I actually have electrical tape over the top of that water pump too because it's got that stupid Corsair logo that you can't turn off. And then there is the SSD inside of the fan controller tray still as well. Still doing fine in there, even though it has minimal airflow in there, and the temps on it are always lower than the mechanical hard drives that sit directly in front of fans, so nothing to worry about. So yeah, definitely happy with the additions. The radiator fans are extremely quiet. They're like 1500 RPM, and an RPM to CFM ratio, they're better than the Noctuas and the Corsairs. The temperature difference on that MOSFET heatsink after adding those fans is night and day. Before, I could hold my finger on it for about a second and it would literally like burn you. Now you can touch it indefinitely and it will never get that hot. So well, I guess that about does it. So that was the journey, and if you enjoyed it as much as I didn't, hit that like button. And if you want to see some more stuff like that, let me know, because I'm always doing projects, always doing stuff like that, and I can record whatever. I don't have a fancy 4K camera or anything, but I can pop on the webcam or the dash cam or something, and or the phone cam, make something out of nothing. So if you want to see that, let me know. Thanks for watching. See ya.